Good afternoon, everyone from sunny Aberdeen, or good morning or good evening, depending on where you're joining us from today. Warm welcome to this webinar hosted by Rockflow Dynamics. Thank you for joining and hope you're all well today. My name is Joanne and today I'm here with my colleague Mike Smith, who will be presenting today's session. So welcome. If you haven't joined one of our webinars before, this is how it will work. So all of the attendees have had their microphone automatically muted. So if you'd like to ask a question, please navigate to the control panel and type your question in there, and we will answer as many as we can at the end. And if we don't have time to address your question live, we will make sure we follow up with you via email. The session is being recorded and we will upload that to our YouTube channel later on for you to catch up if you like. And of course, if you'd like any more information, you can contact us at any time on asktnav@rfdyn.com. So in today's session, Mike is going to demonstrate how to build a simple box model in tNavigator, then link the properties to an automated uncertainty study. We have a variety of webinar topics in this 6-part series, as you can see on the screen here. We also have many webinars on our YouTube channel now, so you can find them there and catch up if you like. If you have any other topics that you would like to see, there is a survey when you exit the webinar, or you can simply drop us an email as well. So we have a wide range of demonstrations from each stage of the integrated workflow. If there's any functionalities that you haven't seen before and you'd like to try them out, please don't hesitate to get in touch with the team for more information and trial licenses. So now I will hand you over to Mike to begin the presentation. Thank you, Mike.
Thanks a lot, Joanne. Hello, everyone, and thanks for joining this tNavigator webinar, especially those who are choosing this over lying out in the sun. Very jealous. I'll do my best to keep it as concise as possible. My name is Mike, as Joanne said. I am a reservoir engineer in the Europe region, and I've been in the industry for about 5 years. 3.5 of those have been with RFD, also as a reservoir engineer. So today we'll actually talk about how to build a proof of concept box model in tNavigator, and we'll outline the reasons why we do this and how it can be done as well. So due to high performance reservoir simulators that utilize modern hardware, reservoir models are increasing in size and complexity. So on average, I guess we see in the North Sea anyway, models ranging from 500,000 to about 5 million active grid blocks, either side of this range as well. In fact, we've been able to run models over 1 billion active grid cells as well. So this is just a kind of average range, but this range is also getting larger and larger through time. These complex models are great for capturing necessary full field detail, but they can also become pretty cumbersome and inefficient. If you want to analyze process or prove a concept, there are lots of different things that play in model simulation that can kind of get away from that, create a bit of noise. We want to kind of, I guess, zone into the things that we want to actually visualize or prove a hypothesis on. So the solution is that we would actually like to isolate the design process, and as I said, just get rid of the noise. So once the concept's been analyzed, the results are then implemented back into the full field model afterwards. And we'll do this by building a kind of tank or box model, or a sugar cube model, as people like to call it. There are loads of different results that you can get from this. But as I said, ultimately you want to throw the results back into the full field model and then prove your hypothesis that way. So you could do resolution testing. So if there's a certain process that you think an upscale model wouldn't be able to capture, you can downscale it until you see it in there, and then downscale your full field model, for example. Different interactions between injectors and producers can lead to different workovers or different schedule changes. Property modeling, static and dynamic analysis leads to the model being slightly amended, or potentially even engaging the G&G team for more geological interpretation. Of course, many others after that as well. So what we're going to do in this demonstration is we will actually build a box model just to show the interaction, and it's a CO2 flood, it's a gas injection flood from an injector and see how it affects the producer as well. It's a heavy oil reservoir with some flow barriers that will actually insert our cells. And after that, we'll actually go forward into the uncertainty world. So we'll put a few variables in there and just do a quick Latin hypercube just to kind of show you how the integration within tNavigator. So the model spec we're using is 80,000 active grid blocks. I'm using a little laptop here. So this is enough for the laptop. It's a 3-phase model. We won't actually see all 3 phases, but the water will contact us below. So we'll see the oil and gas. And of course, we have our CO2 injection well, our production well. It's just a conventional sand reservoir with normal, what you'd expect for the static properties on it. But we have these kind of tight sand flow barriers, which we'll amend as well. We've just done a quick 4-year forecast on it. So how we'll go about doing this in tNavigator? First of all, we'll build a box model. We will then add some static properties with the flow barriers. We'll go forward into the dynamic world, so looking at PBT, rail perms, building these kind of fluids into the model, followed by the schedule, and then the case management, so where we're linking all the different parts of the workflow up with the keywords that we want to use. We'll run the model, view the results, and after that, we'll go forward into the uncertainty. So we'll build a workflow that saves it as a Python script in the background and add some variables to this, run the uncertainty study with Latin hypercube algorithm, and we'll then pick the best model and update our box model with those best variable values. Okay, so we're just now going to go into the demonstration here. Let me minimize that and go straight into tNavigator. So for those who haven't seen tNavigator, this is our kind of integrated workflow. We start all the way from seismic, static modeling, going through into the dynamic modeling worlds, essentially fluid modeling. Up, then we kind of go towards the surface a bit. So we have our well modeling, lift curves, things like that. Going up to surface network, which is fully implicit, all fully parallel as well. Of course, on the right-hand side, then we have our different simulators. So we have black oil, compositional, thermal. And I think this is the kind of jewel in the crown, really, the assisted history matching and uncertainty tool, where you can add variables to any part of this integrated workflow, run them through different algorithms, be that experimental design, optimization, forecast optimization, things like that as well. And so all completely integrated. So we're actually going to start with the area called Model Designer. We're going to select New, just to build a new project. I'm going to add it in here, and we can call it Webinar, followed by Save. So this is just saving the name of the project, and it then opens up the space at which we're going to build our model in there. So at the bottom, you can see we have a kind of log bar. This essentially will tell us every step that we make, if it's complete, if there's errors with it, any warnings that come up, it will tell us. Just for your visualization, I'm actually going to collapse it. So you can do that where you can sort the buttons on the bottom right-hand side. If you click the one that's already highlighted, it actually collapses the log screen as well. So we have our area where we're going to do our visualization. The left-hand column, we have our objects, and the sort of middle-ish column one to the right is our visualization column. Before we actually go into building up a model, obviously you want to look at things like units, coordinate systems, etc. So if you go up to settings in the top, we have units manager. So I'll show you this. We're going to keep everything metric for now. You can see all the different kind of units. You can amend them. You can create your own customized unit system as well. We're happy with this, so we're not going to amend it. And we go to settings again. We have our coordinate systems as well. So if we select, let's say, EPSG, we can then, pick EPSG codes. You can even create your own customized coordinate system now as well. Again, we don't need this. It's a simple box model. Let's make our lives easy and get back into the sun. So first of all, we're going to build this box. So I'm going to scroll down. One of the objects you can see is 3D grids. So I'm just going to expand it twice. We have our properties. We have no properties yet, but when we have our box, this is where we'll add in our properties. I'm going to select main grid, followed by the hammer tool. Okay, so we can see this hammer tool. It's a calculations dialog box, basically. So any objects you have selected on the left-hand side, you will be able to see all the kind of options or processes you can make with that particular object. So we're going to go back to main grid like so. You can import a grid. We have lots of different ways of creating a grid. So if you had horizons or point sets and faults, things like that, you can then add those into the respective areas. You can upscale, downscale. We have different methods of adding local grid refinements into your model, transform the model, etc. We're going to go for create simple grid. And we're going to, this at the top, you have your kind of depth and how many K layers you want to have with your model, and then the length of the grids and the step along, so how long each grid cell is basically. So we're going to start off and we're going to actually put 50 layers into our model. Top depth is fine for us, so I'm just going to make it 2100 as our bottom depth, so 100-meter reservoir. Length, kilometer long, happy with that. We're actually going to refine it a bit from 100 down to 25, so we're going to have 40 layers in the X and Y directions. If you wanted to add in dip angle or azimuth, you can add it in the top. We're going to keep it simple and just hit apply. So now hit play, and let me just close this box. We'll be able to see if I now add a property to it, just a blank grey property. We have a square in the 2D window. We're going to just add some grid lines to it, like so. You can see the grid lines. Again, we can visualize this back in 3D. So I'm going to click 3D tab at the top, just click a random property. And once again, if I add some grid lines to it, you can see that we have our cube. I'm going to save the model. The next step we're going to do is we're going to add our producer and injector wells into it. The easiest way, I mean, there are multiple ways of doing this. We're going to have vertical wells. If you had horizontal wells, you'd create a cross section, and then you'd be able to click into each individual cell to see where you want a connection or a point at which your well would then curve. You can add dogleg severity to your well planning as well. As I said, we're going to go vertical back into 2D. It's a bit easier. And then just right click on any cell that you want to add in a well. So let's go into this particular cell, right click, and you can see add well. So at the top, I'm just going to call this one in, just going to my injector. And the TD, total depth of the well, is going to be 2090. So just off the bottom, basically. We're going to leave things like perforations and the development strategy until a bit later on in the process. I just find it a bit easier for now anyway, seeing as we don't have any other properties. But we're now happy with this well. And I'm going to hit OK. So we now have an injector. I'm going to do the same, just opposite side for the producer. So right click on a cell, add well. I'm going to call it some prod. Again, we've got Z 2090 and hit OK. So these are just the kind of well geometries, if you like. So I'm going to go back into 3D. You can see this, the wells, and if I just untick show grid, you can see how the wells go down. Now, every object you have selected on the left-hand side, you basically get the options in the visualization panel. So if I go into wells just like so, you can see well name depth. We have a scroll bar. I might need to expand it a bit. Scroll bar. There we go. And we can see, obviously, you can scroll the name of the wells up and down. Alternatively, you could even just cut the trajectories by depth. So if I then click cut trajectories depth by depth and then move the scroller along, you can see how the object has been kind of picked up, I guess, and the well name has been picked up. Okay. So we've now added the wells in, and we're going to add the static properties next. And we're actually going to start with our kind of flow barriers, as we talked about right at the start. We're going to infer these in just with a kind of region brush tool. There are loads of different ways we can do this. Of course, from the G&G side, there are much more, I guess, quantitative ways of doing it, fascias analysis, etc. But we're just going to infer them in a different way, let's say, to other webinars so far. Firstly, then we're going to select properties on the top, on the left-hand side, followed by the hammer tool again. And we're going to make the property a value of 0 and the tight sands a value of 1. So we can use those in an if function for our porosity and permeability. I'm going to expand calculator and click on arithmetics. Again, you can see there are loads of different ways that we can add in properties. If you have things like logs, variograms, etc., you have things like all the different types of interpolation. You can go through that in your own time, I'm sure. But for now, I'm just going to select a value of 0. and we're going to call the resultant property flow barriers. Oh, that is a consequence of typing keywords all the time. Capitals, flow barrier. Okay, followed by apply. And we now have a value of 0. Move this to the side a bit. See at the bottom when I move my mouse, you can see ijk, xyz, and then equals the value of that particular cell, so equals 0 in our case just now. Okay, I'm actually just going to close this. And in order to make the regions with a value of 1, which are going to be our tight regions, we're going to first of all create a filter and then open the region brush. So if I expand the main grid at the top, you can see filters, lots of different filters. We're just going to use an IJK filter. So click on IJK, followed by the plus button, and then we have the settings button as well. I'll just move this to the side. So we're going to uncheck everything, make our box go away, but we're only interested in modifying the K layers or Z axis. Okay, you can see if you move the icon down, the scroller down, it takes it now off the bottom, or if I scroll right to the top, you can see the other bar can move it up and down. Okay. So on the right hand side, we have our region brush, show brush configuration. Like so. You can modify the value. We're going to pick a value of 1, it can be anything. We're then going to modify the layer count. So if the easiest way to visualize the layer count is if you go, say, check all, for example, 50, you can see we have a shadow on the grid. We're going to go, I don't know, 3 layers at a time, and you can now see that everything we do, we'll do it 3 layers at a time. So I'm going to make my screen a little bigger. We can then modify the radius, like so, and we can then just start to paint. So I don't know, one flow barrier can be something a little like this, for example, and then let's just scroll through the model, I don't know, to about here. We can put another flow barrier in there. Let's scroll down a little further. Where are we? 30, yeah, go on in. Let's put another flow barrier there. All geologically plausible, as you can see. And a final flow barrier, just like so, okay? So we've got flow barrier 4, 3, 2, and finally the top one just there. So we're now happy with this. I'm going to collapse both of those screens. Again, you can kind of keep the filters. You'll have a list of all the filters there if you want to see them. And we can even just make a quick user cut filter, which would then cancel out all the cells of a value of 0 and just leaving the cells with a value of 1. So again, highlight user cut, hit the plus button. We have our flow barriers property, and we've got non equals to 0, you can do equals to 1 as well, and we have now all of our flow barriers. Okay. And we can just untick that user cut and get our model back. Okay. We can even visualize these in cross sections. So on the top right hand side, you can see this cross section icon, create cross section. Loads of different ways of creating a cross section. We can just do a really quick one. Click on one area of your model, click on a second area of your model. If you hit the cubes, you can rotate the cross section. If you hit the ball, you can move the cross section. We can then visualize the cross section using the cross sections tab. So at the top, we have cross sections. We're now going to assign our object on the left hand side, our flow barriers object, and we get a list of all the cross sections here. So click on the cross section. We can play around and add some grid lines onto it. We can play around with the Z scaling if you like so. And what we want to do then is actually visualize this at the same time as our 3D model. So click and drag, and we can place it at the bottom of our screen. Drag and drop, or click and drag, depending on how you like to say it. And if I find my little expanding tool, there we go. We can see now that if I move my cross section around, let's move that to the side, you can see where our flow barriers are all located in cross section. Once you're happy, which I am, I'm just going to move my cross section back into my main window, click, drag and drop into the center, back into 3D window, and we have our model. Finally, as well, just while we're on the fun bits, if you didn't want a box model or didn't have weren't keen on an azimuth or a dip to it, you can even just amend it, make it an anticline, syncline, whatever you like, using the icon below the region brush tool, show pull configuration. So you select it for horizon or grid. And again, you can kind of define however many layers you want to shift. Let's just shift all layers. This is just to kind of show you some functionality. I'll undo everything. I'm happy with my box. But if you wanted then to, again, move the radius, as you can see, you can then, there are multiple ways of actually modifying your model. So one of the ways is like so, which is proportional. And you can see how, depending on where your mouse is, it pinches the cells above the mouse and creates a kind of anticline, stretches the cells below the mouse. Alternatively, we also have parallel. So this is for your kind of more standard, let's say anticline, syncline, where you can physically just shift the model up and down like so. Okay. Again, all geologically plausible. So I'm going to undo everything I've done, go back to my box. I'm happy with my box, and I'm just going to save my model now. So static properties, so the flow barriers are all done. We're now going to add in a porosity and permeability based on our flow barriers. So we have our property just on the left hand side. I'm going to select properties at the top, followed by the hammer tool once again. So keep it to the side so we can see what we're doing. And again, under arithmetic, we're gonna select a resultant property. We're going to call this one porosity. And we're then just going to add a quick if function in, and I'll have it to copy and paste to save a bit of time here. But we're essentially saying if the flow barriers are equal to 1, which they are, this red area you can see at the bottom is equal to 1, then have a porosity of 0.05, which is 5%, everything else 15%. Hit apply, and then we can see, and if again hover my mouse over it, you can see 0.15 at the bottom for the most of the model, and the center parts for our tight sands 5%. We're going to do the same for our porosity, so our permeability horizontally and vertically. So I'm just going to go KH, and again we're just going to copy paste it in. So if the flow barrier is equal to 1, then have 1 millidarcy, else 800 millidarcy. Hit apply, and then finally for KV, we'll just do 10% of all of that. Makes it easy. Okay, hit apply. You can then just close this. If I add a palette to my model, there we go. So you've got KV. Again, hover the mouse over it, you can see 80 and 0.1. Look at the palette move as well, again, for each model we have. Happy with static properties, we're now going to go into the fluid properties. So scroll down at the bottom, fluid properties. It's going to expand the ones we're going to change. And for most of these, we're going to just reset to, we have some kind of default algorithms in the background dependent on depth, model depth basically. So for a couple of them, we'll just use the defaults, and then we'll actually amend the PBT to be compositional. So I'm going to right click on rock compressibility 1, go reset to default. And it's added a default pressure in there, which is top of your model divided minus your bottom of your model, and then divided by 10 basically. Same for equilibrium as well. You'll be able to see exactly where this comes from. Right click, reset to default. You can see our datum depth is put in the center of our model. Datum pressure is 10% of that. Relative permeabilities, we're actually not going to amend these. We're just going to keep the defaults on them. They seem to work fine for this model. You can double click on the value and change the value. Or alternatively, we also have a rail perm designer. So on the right hand side, it says launch RP designer. And here you have loads more options as to how to build rail perms matched to lab samples. So you've got different variants, different relative permeabilities, capillary pressures. So if you wanted to use, Tomei model, for example, you can use all these. Certainly something to look into. Okay. So we're going to keep these rail perms, and for PBT, I'm just going to select our variant, and on the right hand side, we have the black oil drop. Cool. So back in. This actually uses the same kind of interface-ish to the railperm designer. So we have the RP project on the left, which we were just on, and then we have PBT. PBT designer, compositional black oil thermal, as you can see, this is our black oil now. You can add in different correlations for oil and gas. Same for thermal. Different samples at the bottom for whichever experiments you have. So you can then actually add the experiments in the compositional variants at the top. Go to different phase envelopes, lumping, regression, blend experiments, black oil delumping. Again, in your own time. I'm more than happy to help you with this. We're not going to make the composition up manually. We actually have an E300 import file. So at the top, I'm just going to select import, compositional variance from, and then E3, which is E300. Okay, so just going to pick out my, there we go, pick out my file, and you can see it gives you a QC at the bottom. Anything in orange or red, have a little look into it. Everything's in green for myself, so add the compositional variance, sorry, and you can see the variance now on the left-hand side, different composition there, and we can just close this now. So the last two things we want for our PVT are to add in our standard conditions and then also to visualize this compositional variance. So at the bottom we have more properties. So many properties within this, enhanced oil recovery, for example. If I just expand that to show you, you have the keywords, you have the description of what you're doing. The little question mark will throw you straight to the user manual of that particular keyword. However, if you don't want to search through loads of keywords, you have a search bar at the top. So I'm just going to search the two keywords I want to use, which are stcond. There you go, standard condition. We're happy with these standard conditions. They work well for this model. And again, we're just going to go for one more, which is component data. So it's the keyword component. And you can now see that we can now basically visualize our composition. Now happy with our fluids. So we're going to go on to the well data and schedule. Again, next one down on the left-hand side. And this is where we are going to add in things like our perforations, time steps, different development strategy, etc. So we'll start off with our time steps. We have the time step, the pencil and the clock at the top, the time steps editor. Hit the plus button, and then we have loads of different kind of frequencies that we can use. So I think monthly for about 4 years or so. We can use, works fine for this. So we're going to use today's date for 4 years. Hit OK, and you can now see we have all the time steps available to us, and you can see the lots of ticks at the top now where the time slider is. If I expand well-structured tables, this is where we're going to add in our perforations. So I'm going to add in injector and producer. So it's complaining that we don't have any dates in there. So we actually want to use it on the first time step, which is the 25th. The 6th, 2020. Do the same for our producer as well. 25/06/2020. Events. We want to do this perforation. So instead of having to do individually, actually, we can always just highlight whatever we want to change. Let's do that for everything I want to add into our keyword. So let's say event at the top. At the bottom, you can see a toolbar basically that allows us to populate or multi-edit. So we're going to select perforation for our events. For the top perforation, we want to use it at about 2050, so about halfway through the model. The bottom, actually, we're going to leave blank. It's just the end of, it can be 2090 basically, but it takes the end anyway by default. Depth, measure depth or TBD. And then inside diameter, just 0.16 for everything. Okay. And the next tab along, we're going to go into strategy. So I'm going to expand my development strategy, and you can see that we have our first and last time steps available to us on the left-hand side. If you right-click on one of the checkered flags, you can untick hide step without rules, and you get all of your time steps. Just to keep it a bit cleaner, I'm going to keep them ticked. We're only going to play around with our first time step anyway. So let me right-click on the first time step, select add new rule, and we'll start with wcon prods and then go into the more injection keywords. So you can see well production limits brackets forecast, and if you hover the mouse over it, wcon prod. So I'm just going to double click, add in my production well, bottom of pressure, flowing at 50 bars. I'm happy with that, it works. I'm going to do the same for injectors. So we have injector, read it. I'm going to remove that row. Don't want to put injector in wcon prod, sorry. So I'm going to right click on the top time step again, go add new rule, and then well injection limits brackets forecast. ING. There we go. So we can now add the injector into this one, makes more sense. We're going to change the injection fluid to gas. And we're going to change the control mode to injection rate because we want to see the influence on the producer. The gas injection rate, I'm just going to take it 0 off that to 100,000 meters cube per day. And we can now, we're now going to then add in a couple more keywords that we need for our gas injection. So I'm going to right click again on the first time step, and it's these two at the bottom. So we've got well stream and W-ing gas. Okay. So the well stream, just going to add in the composition. So firstly, we set however many components that we have, which is 10 components. And then we are going to just add in the molecular fraction of it. We're only going to use CO2, so we're just going to keep it like this. And then if we right click on the first time step again, add new rules, the final time we'll do this, we'll inject a gas nature. So you can see as well, we've got well stream, we called it ING gas. So here we're going to link the ING gas as a stream to our injection well, ING gas, like so. We can then QC all of this. Next tab along, we have schedule, and you can see we've got our well specs keyword, well track keyword, comdat and D keywords in there as well, under well definition, and then under well production, we have our wcomprod, ING, and ING gas as well. So I'm happy with this. Let's save the model. And the final part to actually get this up to a model that's ready to be simulated is to go up into our case management system. So top left-hand side, cases, we have our model. And we're going to first of all link our static properties together using the plus button and the static tab. So we have basic grid properties, and it's as simple as clicking once on the left-hand side where the keyword is, and then double-clicking on the right-hand side where your own properties are. Double-click. So we're going to do that for porosity. Perm X, we're going to link to KH, perm Y to KH as well, and perm Z to KD. You can see there we've got bold, and they're all input in the background. If you have multiple grids, you could do this for multiple grids as well. Going to do the same for fluids, just linking them to the tables that we have. So rock compressibility, we have our rock comp table, equil table, rel perm table, standard conditions table, and component data table as well. Finally, selective writing results. So this is where you specify which time steps you would like to save data on. Now, it's split into say properties and graphs, all properties and all graphs, and you can do there's different ways of customizing it periodically, first and last time steps. It's completely up to you. If you have multiple development strategies, again, you could list them and link them together. You can have as many models as you like as well. So it's a really easy way of linking different properties to different models and creating manual different realizations of your model that way. Okay, so the final thing to do actually is to initialize this model. And the way to initialize it is the green button at the top. It'll ask you to save. Ask you where you'd like to save your results. Moment of truth, good, it's always interesting doing live. And now, but if you go back into geometry objects, you can see that, let me close this little bar again. You can see that we now have some additional maps on the dynamic model, and you can see our kind of initial calculator models. So our pressure, oil saturation, obviously, it's all in the oil zone, etc., etc. So what we want to do next is we'd actually want to run the model using the run button. However, in true Blue Peter style, I'm actually going to show you one that I've done earlier. There we go. So this is the model that's been fully run through. And again, if you move the time slider across, there we go. We can see our lovely T for tNav and our flood from our injector all the way to our producer. Okay. So lots of different ways of kind of visualizing this. This is from the 3D window. If you go into the 2D window as well, we have different ways of adding. This is just an average map. Different ways of adding things like contours onto it. So if you wanted to go layer by layer, you could do that. You can look at the sum as well. So it's just looking at all the different K layers. Again, all changes when you move the time slider. And we can also look at some cross sections. So if I go back to 3D, you can see on the left-hand side, I have built a few cross sections. If I tip them on, you can see where the cross sections are. So if we go into the cross section 1, again, you can visualize just some of the flow. and you can see how it travels a little bit across one of the flow boundaries that we have. Again, cross section 2, you can see that as well. Cross section 3 shows some of these flow boundaries that we have as well. So from this case, we want to go forward now into the uncertainty world. To do this, we're going to add some variables, firstly to the permeability of these flow barriers, and then also we're going to change the gas injection rate as well. So to do this, we're going to build a workflow. Top left-hand side, hit workflows, and here you have a list of all the processes possible on the left-hand side. You have your customized workflow in the middle, and then any variables or all of the functionality within that process on the right-hand side as well. You can always do this manually. However, on the project, if you wanted to record your actions, it will automatically populate what you do into the workflows panel as well. And finally, as well, within each process, you have a box that will tell you, ask you if you want to put it into your workflow. So I'm just going to go back into, let's say, KH, hit the hammer tool, and you can see add to workflow at the bottom. So add to workflow, and you can see it's now added that process into our workflows area with the equation, which is very helpful. Again, just going to go on the left-hand side, hit KV, add to workflow, and we can now see that has also been added. Finally, I want to add in this the process to amend our gas injection. So I'm going to hit schedule. Under rules of steps, wells control, we have our well injection limits brackets forecast. So we can just double click on that, and it's just added it to our workflow. You can move the processes up and down using the arrows like so. And we want to then add the wells to this table. I don't want to do anything with the production wells, so I'm just going to get rid of that. We have our injector here. We have our injection fluid, which is gas. We have our control mode, which is injection rate. And I'm just going to leave the gas injection empty or rate just for now, because we want to add variables into this. To add variables, you go at the top, input variables. And I'm just going to make these KH, KV, and then the inj rate variables like so. So it's going to type them in, FB underscore KH, so flow barrier basically, KH, okay. It will give you a base value, minimum value, maximum value, distribution of the variable as well. Again, there's other webinars that will tell you how to do this, so we'll kind of skip that bit just for now. But the first one I'd like to do is just minimum value of 0.1, so 3 orders of magnitude. Okay, we'll do the same for KV, so underscore KV, and we're going to keep this just an order of magnitude lower, basically. So the minimum, so I'm going to do 0.1, minimum value of 0.01, maximum of 10, and finally we're going to go for the gas injection rate. So the maximum rate we want to have is 1 times 10 to the 6. The base will go 1 times 10 to the 5, and the minimum 1 times 10 to the 4. Okay, so we now have our variables, and we just need to insert them into the processes now. So click on the first process. You can see where the 1 is in the middle. Just going to delete the 1. That 1 is obviously the permeability of that flow barrier. And at the bottom, you can see variables, drop-down menu, and you pick whichever variable you want to add, insert in there, and it's between 2 @ signs. So we'll now take the variable instead of the 1. Same goes for KV. What's KV? And finally, for well injection limits, for the gas injection rates, we'll just type the variable in, ginjrat, like so. So this has now been saved as a Python script in the background. We're happy with our workflow. So I'm going to close that. And at the top now, to go into the uncertainty world, we have this magic wand. So I'm going to hit the magic wand, and it's going to ask us to name the project, which you just named it there. You can do a quick start using this launch sensitivity analysis or launch optimization as well. We're going to untick these and just show you a couple more options for the uncertainty, and I'm going to hit OK. It's just going to open up. So this is now into the uncertainty, and we can now see all the kind of variables, different algorithms that we have available to us. If you hover the mouse over them, it will tell you some brief description, but ultimately it will tell you to visit the AHM user guide. We have our variables here. You can select however many variants you want to use from this as well. You can select if you want just graph data, if you want the properties on the last step, which you want to use in this particular case. And once you're happy with this, you press OK, and you can see how the models are being generated. Reading, queued, and you can calculate multiple models if you have multiple licenses. Okay. I'm actually going to stop this just now, go into project info and stop it, because again, being British, Blue Peter are ingrained in British culture to make things as a backup, right? So here's one we did earlier. Again, just from project info, we can see all the variables that we have available to us. So, oh, hang on, is this the right one? Just double check it, sorry. This one will do, I'm sure. So we have the calculations that have been calculated for us. We have some results as well. So, excellent. So we have our Latin hypercube. We ran some models, and we can see actually that we have different gas injection rates. We have the variable values we have for each of the models. So we can move the time slider around just to show you exactly, how the values change through time. So we're going to first of all pick out our. We're going to sort the. Models in terms of oil total. So I'm going to click the top to select whichever one is the highest. So I think this is the highest one. There we go. Cool. And scroll at the top. So for us, it's model number 12. We're going to right click on model number 12, and we're going to select. We can either select view results, for example. So we're just going to open the model up. So we can visualize the oil rates, totals, etc. But ultimately what we're going to do is we want to take the variable values and put them into our model. So I'm going to right click, set variables from this variant to workflow. And then if we go back into the model designer again, so you can see variables in workflow successfully replaced, count of 3. Okay. These can be visualized now back in the workflow editor. So you can see our base value has now changed. And the way to update our model now is to select run workflow. So it's run the workflow. And now ultimately we have at the bottom, you can see the value that we have for our porosity is 0.4 instead of 0.5 that we had before. Okay. So just to finish up from myself. There we go. So to summarize, we built up a box model from a blank page to be a simulation-ready model in order to show how to analyze gas flood and heavy oil using an intuitive and speedy workflows in tNavigator. We then linked it up to the uncertainty worlds, added variables to modify the gas injection rate, kVkh, for the tight stand bodies, and ran multiple realizations in this automated fashion Latin hypercube. The knowledge we gained from this experiment would then be implemented into full field model and rerun to prove the hypothesis that you would have in the first place to initiate the idea of creating a box model, and hopefully more information you'll get from this as well. This overall highlights the kind of seamless integration between multiple processes within one single, fully parallel, fully implicit software. Give it a go. Let us know how you get on. Our global support team are all available 24/7, and they're happy to help. But yeah, thank you very much for listening.
Thank you very much, Mike.
Okay.
We've got a couple of minutes to do some of the questions, so I'll give Mike just a few seconds to have a look at some of those. Just to remind you that our next webinar is going to be on Tuesday the 30th at 9 AM UK time, and that's integrated economic analysis and optimization with myself and Alexandra. So, Mike, do you have a couple of questions there?
Yeah, okay. Whoops. Oh, sorry, that's my fault. Yeah, we do. We have can you model thermal SAG-D model in a similar way? The answer is yes, we can. We actually have some tutorials, similar tutorials on this as well, which are available to you. I think we have well over 100 tutorials with data sets as well. So that could give you a good guide. But yes, if you go back to the kind of EOR area where it said more properties, you'd be able to find lots of different options for models like that. Okay, we have another question. We have, oh, hang on. Was there an option to try and run slim tube experiment for miscibility of CO2 or hysteresis option for non-wetting phase using box model? Yeah, so we can model slim tube. I'll tell you what, the best thing is I'll be able to answer this in more detail once I've done a little bit more research on your question. But ultimately, we've run slim tube models before to look at the miscibility of CO2 injection and hysteresis as well. But we'll be able to, once we finish this webinar, we'll actually send a list of all the questions and all the answers. So we'll give you more details on that for you.
Cool. Okay, let's wrap it up there, Mike.
Yeah.
As you said, if there's any unanswered questions, we will certainly make sure we come back to you personally. Okay, cool. Thank you very much, Mike, for the demonstration, and thank you very much, everyone, for taking the time out of your day to join us. I hope you enjoy the rest of your day. Thank you.